Does talking of integration gives you goosebumps? Then hop on and sit upright as we begin our journey with indefinite integrals. In today's video, we are going to discuss what are indefinite integrals and some standard results and formulas followed by some questions. So let's get started. What is an indefinite integral? So let fx be a function, then the family of its antiderivatives is called the indefinite integral of fx, which is denoted this way. This is known to be the integral sign. The function which is to be integrated is said to be its integrand, and dx represents the variable with respect to which the function is integrated. And the whole process of getting this indefinite integral is said to be integration. Let's see through an example as to why we call it as a family of antiderivatives. Look at these examples. Derivative of x cube is 3x square. Similarly, derivative of x cube minus 1000 is also 3x square. Likewise, x cube plus 30 also gives us 3x square. So what does it signify? If I have to take integral of 3x square dx, then as we all know that integral is actually the reverse process or antiderivative, then ideally we should get the answer as x cube. However, we do not know whether it is only x cube, it is minus a constant or added a constant. Thus, we always represent it as plus c. Here c is said to be the constant of integration, and thus we get all possible answers, creating the whole family of antiderivatives. Talking of few standard results, we see differentiation of integration gives us our original function back. Coming to the second one, integral of k fx, where k is any non-zero constant, then we can simply take this k out and integrate only fx dx. Now if your integrand is a combination of certain functions, then we can integrate each of them individually. So this is the same as integral of fx dx plus minus integral of gx dx. Now combining the second and third results, we can eventually get integration as a linear combination of individual functions. Please have a look at all the results once again. Coming to the most standard formulae in this chapter, please note indefinite integrals is reverse process of differentiation. So whatever functions you see on the right side, if you try differentiating, you would get back your original function. So this is the most important. X raised to power n dx is x raised to power n plus 1 upon n plus 1 plus c. Please note this formula is applicable for all numbers except for n equal to minus 1. Because if you take n equal to minus 1 and try applying this, you would end up getting x raised to power 0 upon 0, which is not defined. However, the moment you come across that, x raised to power minus 1 is 1 upon x dx, which is nothing but your log mod x plus c. If you try differentiating your log mod x, what you end up getting is simply 1 by x. Now, if you come across e to the power x, you are very lucky, because whether you differentiate or you integrate, you get back your e to the power x. Integral of a to the power x dx would be a to the power x upon log a plus c. Please note, whenever you came across this formula in derivatives, you multiplied with log a. However, integration is the reverse process, so you divide with the same number. Integral of sin x is minus cos x plus c. Similarly, integral of cos x is simply sin x plus c. Likewise, secant square x is tan x, cosecant square x is minus cot x, secant x tan x is just secant x, cosecant x cot x is minus cosecant x plus c. When you differentiate the right side, this is what you get. There are certain mistakes which we make while remembering or applying these formula. In order to avoid them, do check out my video on common errors in integration. You can find the video either in the description box below or by clicking the I button. Let's proceed. Coming to the very first question, here we have x raised to the power minus half dx to be integrated. Now we just discussed a formula which said x raised to the power n dx is x raised to the power n plus 1 upon n plus 1 plus c. So you can simply apply this and we get x raised to the power minus half plus 1 upon minus half plus 1 plus c. On simplifying everything, we get 2 root x plus c. Look at the second question, which looks so horrible at the face of it, but if you know all the properties related to exponential and logarithmic functions, it's super simple. Now, in order to refresh all those properties, you can refer to my video on logarithmic differentiation, which once again you can find in the description box or by clicking the I button. So, using the properties, we get this is e to the power log x raised to the power 5, and likewise this becomes e to the power log x raised to the power 4. This one is e to the power log x cube, and this is e to the power log x square. Now you know e to the power log e gives us 1. So here we are left with x raised to the power 5 minus x raised to the power 4 upon x cube minus x square dx. Further, on taking x raised to the power 4 common from here and x square common from here, we are left with x minus 1 in both numerator and denominator. This gets cancelled and we are just left with integral of x square dx. Once again, making use of this formula, we get the answer to be x cubed by 3. No, you must also add plus c. Moving on to the third question, let's use a bit of your trigonometry. You know your cos 2x can also be expressed in terms of cos x as your cos 2x becomes 2 cos square x minus 1 upon sin square x here. Now when you open the brackets, you're simply left with 1 upon sin square x into dx. This is integral of cosecant square x dx, and once again, if you refer to your list of formulas we just discussed, this is nothing but minus cot x plus c. You know we can combine this and write it as ab whole raised to power x, which can further be written as ab whole raised to power minus x dx. Now referring to the formula, integral of ax dx is a to the power x log a plus c. Once we apply this, we get ab whole raised to power minus x upon log of ab plus c. And well, that's your answer. This is just a linear combination of functions. So the integration would be performed on each and every function over here, which means this is going to be integral of x cubed dx. This 5 could be taken out common and this will be integration of x square dx. This will be minus 4 into integral of just 1 dx. Likewise, 7 could be taken common, integral of 1 by x, and similarly the last term 1 upon root x dx. So now if we recollect the list of formulas once again, this becomes x raised to power 4 upon 4 plus 5 as it is into integral of this gives us x cubed by 3 minus 4. Integral of 1 dx would be simply x. Why? Because if you differentiate x, you get 1. So of course when you integrate 1, you should get back your x. So this becomes 4x plus 7 log mod x plus 2, and we just discussed this in one of the questions. that x raised to power minus 1 by 2 dx becomes 2 root x plus c. Now, why am I adding c only once? It simply means you are getting the constant of integration with each of the terms. So, this shall be c1 plus c2 plus c3 plus c4 plus c5, which we have combined together as only one constant. So, you simply get your answer as this. Now in your examination, you need not show this intermediary step, and after this step, you may move on to writing this as the final answer. Now, as we proceed with more complicated questions, then there is no single way of performing them. I would try to use the best way out of my experience, but you're free to choose the method of your choice. Look at this question. We have cos 2x minus cos 2 alpha upon cos x minus cos alpha, where alpha is a constant. So now I proceed this way. I can express my cos 2x as 2 cos square x minus 1 minus we have 2 cos square alpha minus 1 whole upon, we write this as it is. On simplifying, you would see these ones get cancelled. You can take 2 common and we are left with cos square x minus cos square alpha upon cos x minus cos alpha. Now applying your a square minus b square, we get cos x plus cos alpha into cos x minus cos alpha whole upon cos x minus cos alpha. As you can clearly see, this factor gets cancelled and we are left to integrate only this function. So integral of your cos x is simply sin x, and here integral of cos alpha. Most of the students make the mistake of writing this as sin alpha. However, alpha is a constant, so cos alpha comes out and what you have to integrate is only 1. So this gives us the answer plus x times cos alpha plus c, as your cos alpha comes out and you are only integrating 1. Look at the 7th question. Let's go down the memory lane and try to recollect what was our formula for a plus b whole cube. This was a cube plus b cube plus 3ab into a plus b. Now if I can express my numerator as sin square x whole cube plus cos square x whole cube whole upon sin square x cos square x. Now you may ask, why am I expressing the 6 as 2 here and 3 here and not the other way around? It's simply because this would help me create something in terms of sin square x and cos square x in the numerator, which is already present in the denominator. So from here, your a cube plus b cube is a plus b whole cube minus 3ab into a plus b. Thus, this becomes sin square x plus cos square x whole cube minus 3 into ab into a plus b. Whole upon sin square x into cos square x whole dx. Let's simplify your numerator. This is what we end up getting. Now let's separate out the terms and we get 1 upon sin square x into cos square x minus 3. Now integrating 3 is not a problem at all, but what do we do over here? Well, once again it's simple. I can express my 1 as sin square x plus cos square x, separate them out and then let's see the magic. So we write your 1 as sin square x plus cos square x whole upon sin square x cos square x, and let's take this 3dx separately. When I separate these terms out, we would be left with 1 upon cos square x, which is secant square x, and cos square x upon sin square x, cos square x will give us cosecant square x, and this 3 stays as it is. Please note, after separating out the integrals also, I am making sure to write dx with each of the terms. And now, you know integral of secant square x is tan x. This is minus cot x, and this is simply minus 3x, and we add the constant of integration in the end. I hope you all enjoyed this brief introduction to integration. If yes, then you know the drill. Like, share, and do not forget to subscribe. And of course, practice a lot of questions. I would see you with the next video, which would be on integration using substitution real soon. Until then, bye-bye.